In this lesson, we shall focus on Mathematics 1B, MATH141, Tutorial 7. Right, we are looking at power series. And what are these power series in essence? You need to answer the following questions using the series we obtained for the functions 1 over 1 minus x e to the power x, the exponential function, the trigonometric sine of x, and the trigonometric cosine of x. Find a series representation for the following functions in powers of x. So now we want to find this one over here. But we need to remember that 1 over 1 minus x is exactly the same as what? So it has two popular representations. First and foremost, it can be written as the summation of x to the power n from n equals 0 to infinity. But also it can be written as this 1 plus x, x squared, x cubed, and so on. Okay, but yeah, this can then be written as the summation, the infinite series from n equals 0 to infinity of x to the power n. But this converges when the modulus of x is smaller than 1. And this actually is a power series. However, it actually must converge for the sum to exist. Otherwise, this infinite series here diverges. Okay, right. Now, we have this simple problem where we need to use this particular result. So, we've been given 1 over 3 plus 2x. It is 1 over 3 minus 2x. What is this? This is exactly the same as the infinite series. But now this infinite series, must be written, must look like this. So for it to look like this, you must factor out 3. So pull out 3, then you have 1 over 1 minus 2x out of 3. And what is this? 1 over 3, the infinite series from k equals 0. Then now our x looks like this guy, about like this thing here, which is minus 2x over 3 all to the power k. And then we continue from the margin. Let's use a different color. Let's use blue, for example. So you still have the 1/3. Why did you factor out 1 over 3? When you factor out 1 over 3, then you're going to have minus 2x over 3. Now, this is important for us. This thing here, this particular term here is like the x. So in this sigma notation, you now put the minus 2x out of 3. Now, what is this? Therefore, this is exactly the same as the infinite series. Yup. It's exactly the same as this, but now you can deal with this. Write the infinite series like this. K equals 0. Minus 1 to the k. Then you put, there's minus 1, because this 2x over 3 is a negative. And then we have 2x to the power k divided by 3 to the power k. Which is 2x divided by 3 to the power k plus 1. Which is exactly this. Which is exactly that. So we have shown that, but the convergence of these is going to follow when the modulus of 2x over 3 is smaller than 1, because modulus of the x must always be smaller than 1. And then now you can take the modulus of this. So the 2 over 3 becomes positive. The modulus of x is smaller than 1. If you take the reciprocal of this, you cross multiply, it's going to be 3 out of 2, which is this. So this converges as long as the modulus of x is less than 3 out of 2. And this is the answer to the question. Any problem with this? So we used the formula of these. But you see, there are many formulas you might have learned in the class. Like 1 plus x is 1 minus x plus x squared. So it alternates 1 plus x, 1 minus x plus x squared minus x cubed plus dot, 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 like this. Simultaneously, both of these converge when the modulus of x is smaller than 1 in each case. Any question? And then we move to the next problem. Move on.
Sorry,
Yes, please.
I don't seem to understand the concept of this.
Okay, let's do it again. Let's do it again. There's a formula we're going to use. If ever you see 1 over this, we're going to use the formula 1 minus x. What is this formula? What is 1 over 1 minus x? What is the series representation of this? It is 1 plus x squared plus x cubed, and so on. And this is equal to n equals 0 to infinity, x to the power n. It converges whenever the modulus of x is smaller than 1. Now, this is the formula we use. So let us come to this. So here we have been given 3 plus 2x. 1 over 3 plus 2x. Now, this is the same as what? You can pull out the 1 over 3. 1 over 1 plus 2x out of 3. And you have this. So in the end, it's 1 over 1 minus 2x out of 3.
Sorry.
Yes, please.
So basically, the aim is to obtain a value that is sort of kind of like similar to the top
Yes,
thingy,
with a minus, with 1 over 1 minus. So because now they put a 3 here, you have to convert the 3 to 1, to a 1. The way to convert this 3
Okay, so
to 1,
then,
yes, we
so
factor
then
this.
it's
Yes.
okay. Sorry. So then it's therefore not a must to
Yes, yeah, it's not a must. You have a couple of options, yeah?
obtain X.
Yes, but it must look like this. It must be 1 over 1 minus
Okay.
1 over 1
Okay,
minus
understood.
x, so that you can use that formula. So, but now we've converted it to 1 over 1 minus. So this thing becomes our x, this one. And when it becomes our x, then you have 1 over 3, the summation, n equals 0. And then this is raised to the power n, according to this formula. When we have 1 over 1 minus x, you just write sigma, and then you take this x, you put it here, you raise it to the power n, and the summation begins from n to that. But yeah, the examiner used the k here, so you can just use k there. You can just use k there. We can use n, okay, but yeah, they use k here. But when you get to this point, so you have 1 over 3. It's not exactly like what they want, because there's a minus 1 to the power k, so it's an alternating series, this. But we can check because the negative is already there, but we must raise it to the k. So we must just separate things here. So you're going to have the summation k equals 0 minus 1 to the power k 2x to the power k divided by 3 to the power k. So let's continue from here. When you look at this now, let's bring in the 1/3. Which is minus 1 to the power k 2x to the power k divided by 3 to the power k plus 1. So this is what we're getting, which is exactly like this. But you must find the interval of convergence. Right, you must determine the interval of what? Of convergence. Then what is the interval of convergence? The interval of convergence, determine it because this must be, if you have 1 over 1 minus x, to get the interval of convergence, you just say the modulus of x must be smaller than 1. Here you will say the modulus or the absolute value of this one minus 2x over 3 must be smaller than 1. This means that the job of the absolute value is to do this, which is less than 3 out of 2. So that is the answer, which is because this one must be less than 3 out of 2. That is how they put the 3 out of 2 there. So this is the answer. But first, you must just know that 1 over 1 minus x, what is the formula for it? 1 plus x squared plus y. But yeah, but here it's written in sigma notation. So it's not the terms written out. So just write sigma, the summation of the, because it's the x, everything is 1, 1. Even here, everything must be 1, 1. Then you must have minus x. But here there was a plus. So you had to put minus, minus, because there was a plus. Obviously, I'm sure that you might say in class, you might have done the formula with a plus. The formula with a plus is minus, plus, minus, plus. So the formula with the plus alternates. But therefore, if it alternates, its geometric series expansion in sigma notation in terms of k becomes minus 1 to the k x to the power k. So this one that is a plus alternates, okay? But in the question, they said we must use the 1 of 1 minus 1 over 1 minus x. So we're to change the plus to a minus. But if it's plus, then you need to have minus minus because negative times negative is positive. And then you get the answer. Please think about it and make sure you understand. Obviously, we shall go through the third questions. We have a fair chance to understand through the many problems. Okay, try the next one. Right, trying B, it's similar. Now, these must have been powers of x. Powers of x. So what is this? Which is 1 minus x divided by 1 plus x. One minus x divided by 1 plus x. Okay, now this one is a very interesting one, but what do we do here? Okay, when it's like this, normally you need to divide these things. You need to divide them. How to divide this? To divide these things, you need to put, well, the easiest way is to use long division. So in the top, you have this. In the bottom, you have this. You divide this by x, you have minus 1. Divide this, you have -1. You multiply, you have minus x minus 1. You divide this, you have -1. You multiply this, you have minus x, and then you have -1. You subtract these things. Well, this is a long division called the division algorithm or the long division method. So division algorithm, in which case you'd have the minus x plus x 0, and then you have 1 plus 1 giving us a 2. What this means is if you divide 1 minus x by 1 plus x, the quotient is -1, the remainder is 2 over 1 plus x. So that in the end, you have exactly that. So that when you have the 1 minus x divided by 1 plus x, it is the same as what? -1, remainder 2 over 1 plus x. This is -1 plus. It's very interesting that these guys have done it like this. Even if you can do 1 minus, in the place of the x, you put 1 plus x. You divide by 1 plus x like this. So what do you need? You need what? You need to make this one a 2. Because 2 minus 1 is 1 minus x. -1 plus 2 over 1 plus x, which is what we get. 2, and this is k. And then you do the summation. Now you have this one of 1 plus x. But you know the formula. If it is 1 over 1 plus x, the formula is up to infinity, k equals 0 minus 1 to the k x to the power k. Please, it's up to you to let me know the stoppage time. Okay, because we proposed 2 hours, but it's up to you to let us know you are busy at some point, you know. So now, here you have the 1 plus x. The 1 plus x has a -1. So that one is going to have the summation, which is -1 to the power k x to the power k. And then this one is always convergent when by definition in the formula, this one is convergent when the modulus of x is less than 1. When the modulus of x is what? Is less than 1. 1 minus x divided by 1 plus x. Which is -1 plus. So you have this one, but this one now you can see this one starts from 1. So what you need to do then to get this one, because the formula starts from 0, but now they start from 1, so you must substitute. So when you substitute, then you substitute the 0, which is going to be -1 to the power 0, x to the power 0. And then you have this one, k. You have this one, x to the power k. Like this. And then what is this? What is this exactly? So to get this one right now, you're able to get exactly the following. Using the blue color, blue ink, this is 1, 2, -1 to the power k, x to the power k. What is 2 minus 1? 2 minus 1 is 1. Plus 2, the summation from k equals 1 to k minus 1 to the power k, x to the power k. Which is exactly like this, but it converges when the modulus of x is less than 1. It converges when the modulus of x is less than 1. Any question on this one? There are two methods of division normally that are used here, but you're able to see that here we decided to use to change x to a 1 plus x and then decide what number we put here to make sure we preserve the numerator. The numerator was 1 minus x, so no matter what we do to transform it, must never change the expression because it's an equation we're dealing with. So in the place of x, we just put 1 plus x. All right? So this is what we have. Okay, any question on this one? But we've already got the answer, which is 1 plus 2, the summation from k equals 1. Okay, I remember. I made a... This must be up to infinity, please. It's infinity all the way. These are infinite series. Wondering why I put k there. So it must run up to infinity. So these are infinite series. Infinite series. These are infinite series. Any question on this one? Make sure you understand what's happening. But please, the stoppage time depends on you because we're projecting 5. But if you'd like us to stop before that, please, you alert us. Okay. Any question? Anything that you would like us to explain? Anything that you do not understand? Anything that you do not understand? No question. Move on. Let's find the power series of the cosh. Let's find the series of the power series of the cosh. So here there are two things we need to remember, but it is knowledge of the fact that we need to deal with the exponential function. Right, so for example, we know that the cosh of x is e to the power x plus e to the minus x out of 2. So you have this. When you get to this point, you need to think about it and look at what we can do because we must use, according to this, is use the power series of e to the power x. So the series of e to the power x, for instance, we know that e to the power x is 1 plus x over 1 factorial, x squared over 2 factorial, 3 factorial, and so on. K equals 0 to infinity, x to the power k divided by k factorial. So we continue. we continue. Okay. So when you deal with this, then now you need to look at this and think, but think extra carefully. So you can use this particular series to obtain the result. So if you use this particular series for e to the power x, you're going to put this expression. And then for e to the minus x, then it means that wherever there is x, you're going to put that expression. And then you divide everything by 2. Let's check this out. Very interesting. So now, to deal with the cosh, there are 2 ways to get this. You can get this by using the formulas of these 1 over 1 minus x, e to the power x, the sine and the cosine, or you can use the Maclaurin series and the Taylor series expansion techniques that we know. So in this case, this one becomes a Maclaurin series, so you can use Maclaurin series like we did yesterday to get the answer. But here they said, please, these are power series, use the formulas we know. Here. This is e to the power x, e to the minus x over 2. So this one is going to be the infinite series. Okay, let's write it out. I think that's what is gonna help us. First, let's write it out like explicitly. So the e to the power x is 1 plus x over 1 factorial, x squared over 2 factorial, and so on. So which means that it is 1 and then x over 1 factorial. Obviously, x over 1 factorial, we can just write only x. X squared over 2 factorial, x cubed over 3 factorial, x to the power 4 over 4 factorial, x to the power 5 over 5 factorial, x to the power 6 over 6 factorial, plus. Right now, this is what we have. So I'm going to use some different colors here because this is going to be a bit more terms, but this is going to run up to infinity. Then you're going to have 1 e to the minus x. It means that wherever there is x, you put negative x here. So this one is going to be negative x. But if you put negative x and you square it, it becomes just x squared. If you put negative x in the cube, if you cube negative x, is going to be cubed, negative cubed. You put negative and you raise it to the 4th power. Put negative and you raise it to the 5th power. It's going to be negative. Put negative, raise it to the 6th power. So it means that this will cancel out. The x minus x will cancel out. X cubed is going to cancel out with this one. The odd powers are like going away. The x to the power 5 is going to go away. You're going to be left with the even things, okay? So you're going to be left with the cosh of x. We can see is 1/2. Then we're left with what? We're left with 1 plus 1. In 1 plus 1, we know very well it's 2 plus. And then, what else do you have? You have x squared over 2 factorial, x squared over 2 factorial. So there are 2 of those. The 4th power. The 6th power. And so on. You multiply by the 2. So it's going to be times 2 times 2 times 2 there. But it's going to remove this 2, 2, 2, There's a 2, 2, 2, 2. So this thing is going to be 1 plus x squared over 2 factorial. X to the 4th over 4 factorial. X to the 6th over 6 factorial. So now we got this one, and what is this? This you can now write in the desired form, which is the infinite series. 0 to infinity. So now, obviously, this is going to be x squared, x to the 4th, x to the 6th, which means you can write it as x to what? X to the power 2k divided by the bottom, it's 246. 2k factorial. 2k factorial. And then this one is for all x, meaning the modulus of x is less than infinity. So it's for all x that this is the case. Any question on the cosh and the expansion associated with the cosh, the hyperbolic cosine? Any question about the power series of the cosh? But now, if you know the power series of the cosh, then you can get the power series of the hyperbolic sine by differentiation. So if you differentiate the hyperbolic cosine, you get the hyperbolic sine. So you can just differentiate this one. Any question? Any question? Right, so easy. And then the absence of a question, we move forward to the next thing. We move forward to the next thing. We try the next question. We try the next question. Now we have this one, and the same thing applies. But this one, you're going to use the formula for the sine. Okay, so, but yeah, you see, you must use the formula for the sine and the cosine. So you need to remember that whenever you have the sine of x, there's a formula that we have learned there, and then we're just going to write it down, and it is by dint of that formula that we shall. Right, so you know that the sine is x minus x cubed. Minus x to the 7 over 7 factorial. And so, but it goes on to infinity. But you can write it in sigma notation as the infinite series. K equals 0. Okay. Okay. Now you're going to do this one, which is -1 to the power k, x to the power 2k plus 1, divided by 2k plus 1. Okay, so sine x is like, can be written like this. But yeah, you need to use these formulas. So you can write it in sigma notation, or you can write it out in expanded form. Now, with this, then we just use this one. So here we're going to have the sine of x squared out of x. It is 1 over x and then the sine of x squared. 1 over x, what is the sine of x squared? And then now you cube the things like this. You raise it to the 5th power. You raise it to the 7th power. Okay, this is what we have. And then now you can just multiply everything. So this is 1 over x, and this is x squared. X to the 10th, 5 factorial. X to the 14th, 7 factorial. So now, let's write this out. Let's use a blue color now. Which means whenever you have the sine of x squared out of x, what will this be now? So we continue. So which means you have 1 out of x. Okay, yeah. You can just distribute. Okay, so if you distribute, then the 1 over x is going to produce x squared over x is what? It's x. X to the power 6 over x is x to the 5th power over 3 factorial, but it's negative. Plus x to the 9th power, x to the 13th power, Right. So we continue. So now we've already got the answer, but you can see it's alternating because it's positive, and so on. So we continue. Right. So if you look at this now, we're already done. We're already done. Now, what do we do here? Right. So yeah, we continue. Right, right, right. Right. We continue. Okay. So what is this? What is this? Okay, I know that you can be able to easily get this one, but it is alternating, so you're going to have the summation from k equals 0. Because it's alternating, then you have minus 1 to the k. So that when k is 0, then you have a 1. When k is 1, you have negative. So it alternates positive, negative, etc. And then the x begins from 1 to 5, 9, and 13. And this is exactly what you're getting. So it means that the x is going to be exactly 4k plus 1 divided by. The bottom becomes 2k plus 1 factorial. But this is true for all x. So this one we've already got. So let us see what you have here. Let us see what we have here. Right, 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 right. So we continue. We continue. Right. Okay. Any question on this one? So if you say for all x, or you say modulus of x is smaller than infinity. So we continue. Any question? No question. Right. So simultaneously, there are certain things you need to remember. Like the power series of the sine is this one. Maybe we'll have the cosine next. Let's check. I mean, we're gonna send you this recording. So, but we're not running. We're taking our time. Okay, yeah. The next one is this one. The next one is exactly this. So now you have the sine squared of x. So you have the sine squared of x. Right, so the sine squared of x is because of what we know previously about the sine of x, which is x minus x cubed over 3 factorial. Right, obviously we saw the sine is this one. X minus x cubed over 3 factorial plus x to the 5th power. So it's odd numbers, like the number 1, 3, 5, 7. But the signs alternate positive, negative. So it's x minus x cubed over 3 factorial plus x to the 5th power over 5 factorial minus x to the power 7 over 7 factorial. And this pattern continues. Which is plus x to the power 5 over 5 factorial minus x to the 7 over 7 factorial, x to the 9th power over 9 factorial, and so on. K equals 0. It is minus 1 to the power k, x to the power what? We've already seen that precisely for this function. So it is exactly 2k plus 1 divided by 2k plus 1. Like this. So we continue. We continue. So now in the end, then we use this formula. So to do this correctly, the truth is you must write out the series. So now the sine squared is exactly sine x times sine x. So sine squared is sine x times sine x. What is sine x? It's x minus x cubed plus x to the 5th power. Can write this one, it's okay. Minus x to the 7th power. And so on. 3 factorial, 5 factorial, 7 factorial. So which means whenever you have sine squared x, you need to multiply these things out. So you use distribution, so you multiply x with everything. So multiplying x with everything here is going to be x times x squared, x to the 4th power over 3 factorial, x to the 6th power, 5 factorial, minus x to the 8th power, 7 factorial, and so on. Then multiply this by that. 4th power, 3 factorial, okay, you multiply this with this. And then multiply this with that, which is 3 factorial, 3 factorial. Okay, this with that. This with that is going to be minus x to the 8th power, 3 factorial, 5 factorial. And then you multiply this with that. Minus, which is going to be plus x to the 10th power. Three factorial, 7 factorial. All right, that's when you multiply this with that. Then you multiply the x to the power 5 with this. So this would be going on plus this with that. X to the 6th power 5 factorial. X to the 8th power 3 factorial 5 factorial. X to the 10th power 5 factorial 5 factorial. X to the 12th power 7 factorial. Okay, we're good. Now let's check this out and then we can go on, but let us see if anything simplifies out of this. Now, the x squared occurs only once. So we can write x squared. X to the 4th power. X to the 4th power, x to the 4th power. And this x to the 4th power, there are 2 of them. X to the 4th power, x to the 4th power, and then the rest are different. So which means that you have minus 2x to the 4th power over 3 factorial. So we're done with this and this. X to the 6th power. X to the 6th power, so you combine these two. So x to the 6th power is going to be exactly this with this. X to the 6th power. There are many. X to the 6th power, x to the 6th power, x to the 6th power. But these ones now give us x to the 6th power, and there are 2 of them. So these ones are 2 of them. which is 2x to the 6th power. Okay. Right, let us check what is happening here with the x to the 6th power. It is positive. And also this x to the 6th power is a positive. And this one is also positive. Right, so you need to look at this and think very carefully and see what we're having, but it appears that there's a fair degree of alternation. There's a fair degree of alternation. So we continue. Okay, now we need to simplify this and show that it simplifies to this. But you can see that surely this term appears that it's going to be there. But you must look the x to the power 4 with this, because now it's going to be 2 of these. Now the 3 factorial is 6. Divide 6 by 2, you get a 3. Okay, something you need to think about, because whenever here you put k equals 1, it's going to be x to the power 4, and it's going to be divided by 4 factorial. But over the 4 factorial is going to have a 2 there. So if you put 1, it's going to be 4 factorial 4, and then this one is going to be 2 to the 3, 8. It's going to be 8 with the 4 factorial. And the 4 factorial is the 24. Yeah, it works out. 4 factorial is 24, and then it's going to be an 8, which is going to bring 1 out of 3. Yeah. This is okay because it's negative 1 out of 3. So this is fine. Then when you put k equals 1, that's what you got. When you put k equals 2, it's going to be 2 times 2 is a 4, plus 2, 6. So next term is going to be x to the 6. You put a 2, 2 times 2 is a 4, plus 2, 6. Put a 2, and then it becomes 2 times 2 is a 4. A 4 plus 1, it's a 5. Right? So we continue. So we continue. We continue. Okay. 2 to the power 5 is a 32. X to the power 6. This one is 6 factorial. What is 6 factorial? Right, let us check it out. So we're dealing with 6 factorial. 720. So if you have 720 and then you have 32 out of that. Just trying to study these numbers. 32 out of 720. 2 out of 45. 2 out of 45. So it means therefore you're going to have 2 out of 45 with x to the 6th power. Like this. Okay, so this is going to be for the x to the 6th power. For the x to the 6th power. Two times 2, it's a 4. Plus 2, 6. And we have x to the 6th power. So now I want us to look at the x to the 6th power and analyze it carefully. So we take our calculator. Then we're going to analyze this carefully. So we have x to the 6th power that appears here. So we got 2 out of 45. Let's take 1 out of 5 factorial. 5 factorial. Plus 1 over 3 factorial. 3 factorial is like 6 by 6. This one. For x to the power 6, x to the power 6. 3 factorial is like x 6 by 6, yeah? One over 5 factorial. Exactly 2 out of 45. This is a miracle. It is miraculous. It is miraculous. So that is the answer. So if you add 1 over 5 factorial with 1 over 3 factorial, and 1 over 5 factorial, it gives us 2 out of 45, which is what we want. We're done. So in the exam, you write like 3 terms like this. Generally, you're done. Okay, we can go on to x to the power 8, but yeah, we're done with x to the power 6, x to the power 6, and x to the power 6. Either way, when you all look at all these here, okay, but obviously it goes on. Just decided to write 3 terms. And then if you continue with this, it goes on and on and on. But you saw that the 2 out of 45 is going to produce what they want. So this is the infinite series. K equals 0 minus 1 to the kth power, 2 to the power 2k plus 1. X to the, yes, please.
Yes, may I ask, why do we always include the -1 to the k power?
Because the signs alternate, yeah? Because it's positive. The first one is positive, the next one is negative. The next one is positive, and in this case, the next one is going to be negative. So because the sign, if the signs alternate, then you must always include the -1 to the power k to take care of the alternating signs. Okay?
So if they don't alternate,
then we leave it out. Then they cannot be -1 to the power k. Everything is positive, or everything is like plus.
okay.
So that is what happens, yeah. So we're good. But now we got this one, but you saw that was a bit hectic. In particular, it involved a multiplying series, because we got the series for sine x and then another one for sine x, and then because it's sine squared, then means you need to square that series to square the series, they need to multiply term by term and then add like terms and so on. And we did that. We did that, and therefore we got the answer.
Sorry.
Yes, please.
Yes, I don't understand how we got to a final answer. How do you get the final answer?
The sigma notation.
Yes.
This one here.
Yes.
Because now
How
we need
do
to
you?
check. Yes, how do we get from here to here?
Yes.
Okay. Obviously, because we argue that this is exactly the same as this. So if this is exactly the same as this, it means that you need to check when you put k equals 0 here, you must get the first term. Because we wrote like 3 of the terms. When you put k equals 1, we must get these. But you saw that when we put k equals 2, when we put k equals 2 here, we got 2 out of 45 here. 2 out of 45, which is the 2 out of 45 here, which we got when we use the calculator for the x to the power 6, 1 over 5 factorial, and then 3 factorial, 3 factorial, and then 1 over 5 factorial. You get the point? So now let's check. If you put k equals 0 here into this, we must get x squared. Put k equals 0. If you put k equals 0 minus 1 to the power 0, it's going to become 1. It's going to become 1. 2 to the power 2 times 0, it's going to be what? It's going to be 0. And then plus 1, it's going to be just 2. And then it's going to be x to the power 2 divided by 2 factorial. And this gives us x squared because 2 factorial is 2. So if you put k equals 0, you're getting x squared. So indeed, this is equal to this. Because we also got a 245. Now, if we put 1, then we're going to get the negative minus 2 over 3 factorial, which is what we did. We got that one. We got 1 over 3. When you put k equals 1, we got 8 over 24. Because when you put 1, this is going to be 2 plus 2, which is 4 factorial. 4 factorial is 24. And then if you put 1, 2 times 1 is 2 plus 1 is 3. 2 to the power 3. What is 2 to the power 3? Is 8. 2 goes how many times into 24? 3 times. And then this is a 3 factorial, this. This 3 factorial divided by 2, you get 1 over 3. So indeed, if you put 1, you get minus 1 over 3. But this minus 1 over 3 is what we got when you put 1. So indeed, these 3 terms are equal to this, because when you put 0, you get x squared. When you put 1, you get minus 2 out of 3 factorial, which is minus 1 out of 3. When you put 2, you get 2 out of 45 there. So even when you get the next term, what will the next term be? Because x to the 6, the next term is going to be x to the 8th power, which is this, x to the 8, x to the 8, x to the 8. There are 3 of them. You add them up, and then you're going to get the next term. So indeed, this equals this, because when you put 0, you get x squared. When you put 1, you get minus 2 over 3 factorial, or minus 1 over 3. When you put 2, you get 2 out of 45. If when you put 3, you're going to get it. You can check with the calculator. So I'm going to check with the calculator when you put 3. Okay, so, but I cannot doubt, so that is why I did not. So when you put 3, you're going to deal with 8. When you put 3, k equals 3. When k equals 3, what is 2 times 3? It's 6. 6 plus 2 is what? It's 8. 2 times 3 is 6 plus 2 is 8. Two times 3, it's 6 plus 1, 7. If you put 3, then there's going to be a negative. There's going to be a what? A negative. Now, want to get the coefficient here, so you can just use a calculator. Because we just need to get the coefficients here and just compare that is the same as this for term by term, and then we're done. Okay, because that's what you can do. So now let's come to this. So now, because this would take generally a lot of time, because these are number patterns, the coefficients of these would involves number patterns, geometric and whatnot. These coefficients like 2, 2, you know, so, but you don't need to scratch your skull, because they've already given you these, but you just need to check that indeed this is equal to this term by term, and then you're done. Okay, now if you have like 2 to the power 7, 2 to the power 7 here, you divide by 8 factorial. So it is exactly 1 over 315. 1 over 315. Okay, that's what you're getting. Because we tried with the calculator, 2 to the power 7 over 8 factorial is minus 1 over 315. Minus 1 over 315. Now, let us do more. Now we need to check with the calculator. The x to the power 8, we expect it to be minus 1 over 315. When you do the x to the power 8, let's do it with the calculator. We're just comparing that indeed these terms of ours are equal to the sum formula that is given in sigma notation. So let us do this x to the power 8, but also there's no other x to the power 8 there. So this is the last one. So I'm going to put the calculator up here. And then we're going to do x to the power 8 is minus 1 over 7 factorial. Put negative like this, and then put 1 over 7 factorial. 1 over 7 factorial. Then x to the power 8 is minus what? Which is 1 over 3 factorial. 7 factorial. Okay. No, it's 3 factorial, 5 factorial, yeah? Okay, we're just putting these things here. For x to the power 8, want to compare. If these things are the same, then it must be like minus 315. Okay, we hope we're not leaving any x to the power 8 term, because there's minus 1 over 7 factorial, then there's minus 1 over 3 factorial, 5 factorial, and then there's minus 1 over 3 factorial, 5 factorial. Minus 1 over 3 factorial, 5 factorial. Three factorial, 5 factorial. Like this. Okay. Okay, something it did not like. Let me check. I can maybe we can put the times here. I think that it did not recognize this minus I've used. Use this minus here. Make sure I use the same minus here. Delete, I use this minus. Doesn't matter because it gave error, so it did not recognize an input. Times. Right, so now it gives us exactly that. So there might be an x to the power 8 term that is missing, minus 1 over 7 factorial, and then you have the minus 1 over 3 factorial, and then there's minus 1 over 3 factorial, but yeah, there's x to the power 8. So yeah, there might be an extra term that we need to add to get the 315. So it's okay, we've got the first 3 terms, but I was just doing the x to the power 8, x to the power 8, and x to the power 8. It appeared to be like 3 of those so far, but you're able to see that there might be an extra term that we need. But obviously, you can't write 100 terms, just write 3 of them. You don't have the whole day in the exam to just do one problem like this. Multiplying series normally is texting. It involves a lot of stuff. 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 Any question? Think about it. Right. So now just think about it and make sure that you understand. Okay, just um so yeah. Any question? Think about it, but yeah, this will be the answer to that in short. But you can write like 100 terms, there's no point. You can even make mistakes there, etc., etc. So 3 terms are generally enough. An examiner they're enough to show that indeed this then is equal to this. You can't show, there's nothing to show that this is equal to this sigma notation because it's already given. But we might just write out some of the terms. That is how you can show some of the terms. And then the examiner is going to see, this student got 3 of the terms. Indeed, these things are equal. So, yeah. Because you can see the coefficients of this exactly are produced by this thing here. Produced by that thing there. So any question? Any question? Okay. You appear to be quiet, so we can move on to the next question. Okay, obtain the series expansions of those. Okay, some of these things you're going to do them. Let's see now. This is number 2. Then what about number 3? Yeah, that's okay. So let's do number 2 now. Obtain the series expansions for these in powers. So here we are close to the kinds of things they speak about in the test scope that you must know how to differentiate and integrate power series for the test. So now we're going to do that. So this one must be in powers of x plus 1. So it is e to the power 2x plus 3. Okay, we continue. So now this 2x plus 3 must be in powers of 2x plus 1. So which means that imagine powers of x plus 1. That's what we say. In powers of x plus 1. So the e to the power 2x plus 3. What is the x? The x is x plus 1. So wherever there is x, you put x plus 1. Then you need to think of what to put here. Now, 2 times x, because everything must be in powers of 2x plus 1. Yeah, in powers of x plus 1. Then you'd have 2x plus 2. Then you need to add a 1 here. But this e to the 1, you can put it here. Then it's e to the power 2x plus 1 like this. And hence
Sorry.
e. Yes, please.
May I ask why do we add it 1?
We added 1 because when you multiply this thing, it must be the same as what we were given before. So 2 times 1. This is going to be 2x plus 2. If you
Okay,
multiply
like
2x plus 2, so you need to add a 1 so that we still have the 3. Okay. But this 1 that we've added, that must still maintain the 3, now produces e to the power 1, which is what they got here. And then now we can write the e to the power 1 first because it has been written outside. It's a constant. And then we have e to the power 2 to the x plus 1. And then now we know at this point the following, that the e to the power x is actually equal to the infinite series. This one don't need to write out. From k equals 0, x to the power k over k factorial. So e infinite series, k to the power 0, 2x plus 1 to the power k divided by k factorial.
sorry.
Yes, please.
Yes, may I ask the thingy that you wrote there where you said e to the power of x is equals to the sum
Yes, so
is
x to
x
the
to the
power
power
k.
of k.
Yes,
Yes, over k.
factorial. Yeah,
Yes. Like how did you obtain that? Is that a thing that we have to
it's a
know?
formula. Yeah, it's a formula. But how did you obtain it?
A formula based on what power series or
Yes, yeah, it's a formula based on, it's called the power series formula for e to the power x.
okay.
But if it's a power series formula, we obtained it using the origin of these because the question is, where did it come from? Generally in mathematics, it came from Maclaurin series. But you can't be using Maclaurin series here because here they said just use the formulas of E. So when they say they use the formula of E, then you need to know that e to the power x is power series. Is e to the power x is the sigma notation from k equals 0 to infinity, x to the power k factorial. You know? And so now we use it. But here it's not e to the power x. It is e to the power 2 in brackets x plus 1. But now this thing becomes our x, this becomes our x. So wherever there is x to the power k, then we're going to put 2 in brackets 2x plus 1. All to the power k, then there must be a k factorial, the sigma notation is there. And then this thing is,
okay, sorry.
yes,
May I also ask why did we times by the e next to that
sigma.
formula? Yes.
Yeah, because the e is coming from here, the 1, e to the power 1. From the fact that if you have e to the power a plus b, e to the power a plus
Mm-hmm.
b, e to the power is e to the power a times e to the power b, isn't it?
Mm-hmm.
Okay, so generally, if you have e to the power a plus b, or you can say e to the power like x plus y is e to the power x times e to the power y. You know, you can separate the things like this. So it's e to the this plus this is e to the power 1 and e to the power that. But we're putting the e to the power 1 because it's a constant first. And, you know, and then you can write the rest of the things after. But the e to the power 2 in brackets x plus 1 is the same as e to the power x. What is the power series for e to the power x? Which is the Taylor series, the Maclaurin series, same thing. Right, so it is e to the power x, the summation of that in sigma notation is k to the power 0 to infinity x to the power k divided by k factorial. You know? And then in this case, it then means we already know the power series for these, which is this. And then we can just separate the things here, which is 2 to the power k, x plus 1 to the power k divided by k. You can put the k factorial here in brackets, but it's just no need for the brackets. And this is true for all x, or you can say modulus of x is, absolute value of x is less than infinity. Which is exactly this. you know. So we've already solved that one. But here, because it involves E, you must know the formula, the power series formula for E. It is this one. Any question? Think about it and make sure you understand. Make sure you understand. Right. Any question? Okay, I'll assume that you sort of understand what's happening. Let's try the next question. Let us try the next question. So we're going to do B, this one. But now we're going to do 1 over x, but it must be in powers of x plus 5. To be in powers of x plus 5, then you need to put, next to the x, you must put a plus 5, but you know you must subtract the same thing. So because the x must be made x plus 5, wherever it's x, you must put a plus 5, but you must subtract the same thing. Then when you get to this point, it must be in x plus 5, so you must pull out something here. So you need to pull out minus 1 over 5 so that you are left with 1 in the place of this. X plus 5 out of 5 like this. So yeah, it's this. So when you multiply by the minus 5, then it's going to be minus 5 times 1 is minus 5, and minus 5 is going to cancel. And then this one, you already know 1 over 1 minus x. There's a formula that you must know there. It is this one for the geometric series, but you can know it. We know it in sigma notation from k equals 0, x to the power n. So this thing here is our x. So we must write minus 1 over 5, and then we put k equals 0, x plus 5 out of 5 to the power k, like that. So that now it becomes this. But we're not done yet because it doesn't look exactly like this, but this 5 must go in. So which means that you're going to have minus 1 over 5 which is minus 1 over 5 to infinite series. And then it is to the power k, so you put to the power k and then the 5 to the power k. And then this 1 over 5 you must multiply through. When you multiply through, you have the infinite series. So you're already looking at the answer. We're very close to that. We have everything. This negative now will be put in front here. X plus 5 to the power k, and then 5 to the power k plus 1. Okay, we continue. And then you must take the modulus of this thing for convergence. For convergence, then you take the modulus of x plus 5, because this one is convergent.
Sorry.
Yes.
May I ask, how did you obtain the k plus 1 in the denominator?
Because there's 5 times 5. 5 times 5 in the denominator. It's
Okay.
5 times 5 to the power k. Right? So this 5 here in the denominator is to the power 1, and therefore 5 to the power 1 times 5 to the power k is 5 to the k plus 1. And this negative is this one. And the x plus 5 to the power k has been brought forward. But here the x plus 5 out of 5 must be less than 1 for convergence, which means that x plus 5 must be less than. So this 5 times 1, you multiply, it becomes this, which becomes minus 5 is less than x plus 5 is less than 1. And then at this point, then you then say is less than x plus 5 minus 5 is less than, yeah, and then it is 5. Yeah, so you get this. But now you have this. So whenever you have this, now you subtract 5 from each of the sides. So which means you have minus 5, then you subtract 5. Subtract 5. Subtract 5. Is 5 minus 5? Minus 10. X is 5 and 5, 0, which is this interval of convergence. So the minus 10 to 0 is obtained by saying the modulus of this guy. Like in this case, if it's 1 over 1 minus x, 1, 1, and x, 1, 1, and an x thing, the modulus of x is less than 1. So the modulus of this is less than 1, which means the modulus of x plus 5 is less than 5. Which means minus 5 is less than this. Which means minus 10 is less than x less than 0. Which is the interval of convergence. Interval of convergence. Any question? Any question? So we've already got the answer. So please think about it. Think about it. Think about it. Think about it. So any question? Right. Well, we continue. We continue. We continue. Think about it and make sure you understand this one, because we shall move to the next question. So here we're to write 1 over x in powers of x plus 5. It's very tricky, this question, but very tricky, because it is 1 over x, and you must write it in powers of x plus 5. The question is, where is going to x plus 5 come from? Where will x plus 5 come from? So you must then say, wherever there is x, you put a plus 5. But if you put plus 5, you must subtract the same thing, because 5 minus 5 is 0, not changing the original question. Yet a transformation becomes necessary to actually be done like this. Please, these questions, we need to discuss them. We need to have a discussion and a debate. I must give you some questions to try during our discussion, because these are like few, but we're showing the extremes of this topic. But it's not all. It's not everything. Next question. Use differentiation to show this. Right, so obviously there are a couple of ways to use differentiation. Now, for this one, enhance, find the Maclaurin series for this. Okay, very easy. But look, this first one can be done in 1 billion ways, but one of the ways is to say 1 over 1 minus x, we already know its power series. It is this one. And then you put x to the power k, and then we have the modulus of x less than 1. You already know the 1 over x. But this 1 over 1 minus x can be written like this. And then you find the derivative. So, and then you have k equals 0, x to the power k, and then the modulus of x is less than 1. Okay, now you find the derivative both sides. Because this 1 over 1 minus x, we know it's like this. But 1 over is the same as x to the power minus 1. And then you can just differentiate both sides of this, because it's an equation. We put dtx on the left and dtx on the right. The derivative of this one by the chain rule is minus this, minus 2. Then derivative of the interior is minus 1. The derivative of this summation is kx to the k minus 1. So we continue. So that then in the end, you have negative, negative, which becomes a what? Negative, negative becomes a positive. But the power negative 2, you can write it like that so that it looks like this. And then this is the infinite series. K equals 0, k to the power k minus 1. Okay, so you get exactly that. You get exactly that. But at the point that you differentiate, this must change to a 1. At the point at which you differentiate, you change this one to a 1. Okay, it's a bit tricky to see when you're just differentiating. It's a bit tricky to see. Okay, but now you can do it like, you can also look at the fact that 1, which is easy, I believe. The 1 over 1 minus x is 1. You can write it out so that you can just differentiate this one. Is 1 plus x squared plus x cubed. Plus x to the 4th power. You can write like this. Then now next, this 1 over that is the same as this. So yeah, you can put x to the 5th power. Let's find the derivative. d dx of this. So we continue. So that this thing here, you find the derivative of this is minus. You bring down the -1. You find the derivative. Okay, derivative of the interior becomes find derivative. Derivative of the 1 is 0. Derivative of the x is 1. Derivative of the x squared becomes what? 2x. The derivative of x cubed is 3x squared. Of x to the 4th power is 4x cubed. X to the 5th power is 5x to the 4th power. So that in the end, this one, negative times negative is a plus, giving us 1 over 1 minus x, and then you square it. So if you look at this summation here, it is the same as the summation. Because if there is a number here, if there is 3 here, the top is 2, 1 less. If there's 4 here, the top is 3, 1 less. If there's a 5 here, the top is 1 less. So there is a k, and then the top becomes 1 less. So 1 less is a -1. And then now, if you want to decide where to start here, you can see that here you need to start from k equals 1. Because when k equals 1, it's x to the power 1 minus 1, 0. And then it becomes 1. When k is 2, you have 2, but 2 minus 1 is 1, giving us 2x. And this runs to infinity. And then obviously this one here from this converges whenever the modulus of x is less than 1. And then we are done with this. So we use the differentiation to actually show this. And then next, the question says hence. So hence we shall find the Maclaurin series of the cube now. Hence we shall find the Maclaurin series of the cube. So we continue. Right. Right? Got the answer? Any question? We're learning how to use because the test is going to have things like this. But you must know something. You must know, like, they can give you the 1 over 1 minus x because you already know that 1 over 1 minus x is this. Then you can just differentiate both sides like we did. Now, you can find higher powers, like when now it must be this. What do you then do? What do you then do? So you continue now, you need to find the next one. We're dealing with, okay, they're saying hands. You have 1 minus x, you square it. It becomes this. How do we know this? Okay, this one, we only know this. We only know this, and then we can get the rest. 1 plus x, 1 plus x squared, x cubed, and so on. And then the rest we can get. Both these. Okay, so this is the case for x less than 1, yeah? So this one, they are saying hands, so we must use this. But now they want us to get the cube. Now we need to think a little bit. How do we get this cube from the square? How? How? I mean, there are a couple of ways you can use to do this. And the way to do it can be to say, you already know one of them, like the 1 minus x squared. You already know this one, 1 minus x squared, which is this. And then you just need to get this one. So you have two series to deal with. The 1 over 1 minus x is this one. Okay, yeah, let's get this one. And then this one is exactly this, but we saw that this one of the is exactly what? 1 plus 2x, 3x squared. 3x squared, 4x cubed, 5x to the fourth power, okay, so this is what you have. So you have two series to multiply, like we did. Let's first multiply 1 by 1. 1 times everything. 1 plus 2x, 3x squared, 4x cubed, 5x to the fourth power, and so on, plus. You multiply by 1, then multiply by x. X by 1 is x. X by 2x is 2x squared. X by 3x squared, 3x cubed. X by that, 5 to the fourth power. X by that, 5x to the fifth power, and so on. By x squared. X squared, 2x cubed. 3x to the fourth, 4x to the fifth, 5x to the sixth. Let's do auditing. Constants is only one number that has no x. The x term, there's a 2x, x, which gives us 3x. Only that. 3x plus x squared. There's a 3x squared, 2x squared, giving us a 5x squared, giving us a 6x squared. 3x squared, 5x squared, 6x squared. X cubed, 4x cubed, plus 3x cubed, 7x cubed, 9x cubed, and so on. We're getting this. Now, this must be the answer. So now we need to look and think. The coefficients 3, 6, 9. They must form a quadratic sequence. So, okay, to see this now, just substitute. When k equals 2, this thing is going to be 2 over 2, 2 minus 1, 1. X to the power 0 is going to give us 1. When k is 3, 3 minus 1 is 2, so this is going to be 3. X to the power 3 minus 2, it's a 1. So indeed, you can see that this one is exactly the same as that. You don't need to, there's nothing more to do. It's exactly the same as these. Because you have written out the terms. So and the examiner who's going to mark your script is going to see this is equal to this. So this is the answer. Any question? Any question? Right. Any question? Any question? Any question? Any question? Any question? Any question? I think that we're going to stop here for now. Then we shall continue later on. Going to continue later on. Maybe I can do one more. Let's do integration of power series. Let's do integration of power series. So now, if you have so this one now, you need to show this one, that the ln of 1 plus x is that one. Use integration. So now, what you need to do here is to then say, yeah, let me see. Okay, that's fine. Okay. Okay, just 1 second. Yeah, you're saying that obviously suggesting that we explained from scratch the topic for Taylor Maclaurin in power series. Okay, let's see. Never mind. I'm just trying to read the chat, please. Right, suggesting that can you please explain from scratch the topic for Taylor Maclaurin and power series, because you have been lost since class. Okay, I just don't get them. When do we use them? And I don't know how to approach the questions. Okay, good. What we can do, let me just do this example now, and then we shall get back and recap on everything. Okay. Right, we shall recap on everything. But let's start by saying 1 plus x. 1 minus x. What is the 1 plus x? It's 1 minus x plus x squared minus x cubed plus x to the fourth minus x to the fifth and so on. So this one you already know. I know that it is very popular in your class to say use the top of the chart. They said use the 1 minus x. So in the event that is 1 plus, they might say use minus this. Use minus this. And the minus this now is going to be 1 minus x plus x squared minus x cubed plus x to the fourth power minus x to the fifth power plus x to the sixth power minus x to the seventh power and so on. In which case, so we continue. Okay, we'll continue with this. Yeah, I want us to discuss this integration technique. But first you write down this formula and then you're going to integrate both sides. When you integrate both sides, you integrate the 1 over 1 plus x. Simultaneously, you integrate 1 minus x plus x squared minus x cubed plus x to the fourth power minus x to the fifth power plus x to the sixth power minus x to the seventh power and so on dx. So if you integrate this, what you get? The integral of the 1 is x. Of x, it's x squared out of 2. X squared integral is x cubed out of 3. Okay, let's check this out. X to the fourth, x to the fifth, x to the sixth, x to the seventh, x to the eighth. So you have this. Okay, so now this one is alternating. So we're going to do the summation from k equals 0. You can put it here. The summation from k equals 0 to infinity. And then it is the minus 1 to the kth power because it's plus, minus, plus, and so on. And then x to the power. So because this is 1, 2, 3, 4, 5, it is like that. You can start from 0 and then put k plus 1, and then you divide by k plus 1 because it is exactly like this. So when you put 1, when you put 0, it becomes exactly this. When you put 1, it becomes 1 plus 1, 2 over 2. When you put 2, it becomes 3 like that, which is exactly that. That is what we're getting. That is what we're getting.
Sorry.
Yes.
Yes, can you please re-explain how you got the x to the power of k plus 1 over k plus 1?
Okay, we studied the patterns here, and because what you are able to see that this is the series we're getting. You look at this result they've given you, and then say when k is 0, do you get that x? When k is 0, it's going to be 0 plus 1, which is 1. X to the power 1 is x. Because the bottom is going to be 0 plus 1, which is only 1, and this one is going to be minus 1 to the power 0, which is 1. So indeed that when k is equal to 0, you get 1. You get x. When k is 1, you get minus 1 to the power 1. It's negative. 1x to the power 1 plus 1 gives us a 2. 1 plus 1 gives us a 2. K is 1. When k is 2, you square minus 1, you get a 2. And then we have 2 plus 1 giving us a 3. 2 plus 1 gives us a 3. So indeed, this is the same as that. Because you've got the terms, you can be able to say it is that, because when you change the case, it gives each of these terms. So indeed, these things are equal. So there's nothing to show,
Sorry.
there's nothing to show. You do it term by term. When k is 0, you get that. Because the formula is already given. So
Okay.
yes, because the formula is already given the question. But also the integral of this, what is the integral of this? The integral of this becomes the ln. Right, it becomes the ln of the 1 plus x modulus. The 1 plus x modulus. K.
Sorry.
And then you can put some round parentheses here. But you see, what we've been able to do, we've been able to get a series by dint of what? By integration. You see, the formula is already given. But what you need to do, you need to get the terms. When you got the terms, then you just confirm that when you put k equals 0, you get x. When you put k equals 1, you get this term. When you put k equals...
Sorry.
Yes, please.
Yes. So since you're saying you looked at the formula, so what should we do in a case where we're not given the formula?
Then you can leave it in expanded form. Okay, you can leave it in expanded form because generally, if you're not given this formula and they say find the power series of this, it's equal to what? Then you can just write it like this. But then you can work out this formula, but working out this formula is going to be like, it's not part of what you need to do because it's like high school a little bit. Because what you need to do is to say the denominator is 2, 3, 4, 5, 6. It's number patterns. So you can write the numbers. 1, 2, the denominator is 3, 4, 5, 6, 7. Okay. So now, normally we start from 0. So, but you need to get a 1 from 0. If you put k equals 0, you need to get a 1, then you must make it k plus 1. So the denominator is going to be k plus 1. But also the power of x must be 1. But you start from 0. So you must put k plus 1, so that when k is 0, then you still have a power 1 on x. Minus 1 to the power k is, you always put that because the signs alternate. And voila, we have the formula out. Yeah, but it might not be unique, this. So you might start from 1. Another student can start from 1, in which case it's going to be different a little bit, but it will be equivalent because, another student can start from 1. How can you start from 1? There are many formulas you can get that are all correct. So, but in this case, it's given. So it's not unique. It doesn't mean you can all get the same formula. So generally, writing it out like this is okay. But for example, a student can say there's x in the beginning, and then there's x squared. Then the student, they can say the signs alternate, and then you have minus 1 to the k plus 1. And then x to the power. Then the student will come and then say, the x is to the first k, this one. So you can put here, suppose the student says they want to start from 1 to infinity. So if you want to start from 1 to infinity, then you can start from anything, obviously. It's open. There's no rule that says start from 0, k equals 0. So you start from 1, then you have minus 1 to the power k plus 1, which is that. And then you would put x to the power. Then you need to think of the x. So the x must be 1, so you can put k here, because you have x to the 1. And then you divide by... the next thing. So you start from 1, so you can divide by k. Because if you start from 1, then it's going to be, put minus 1 to the k plus 1, then it's going to be exactly 1, and then x to the power 1 over 1. You put 2, is negative 2 over 2. You put 3. 3 plus 1 is a 4. And then, yeah. It's a 4 giving a positive share, and then this is a 3, 3, 3. So this formula is also correct as much as that one is also correct, but this one starts from 1. You know, another student can come with a formula start from 3, but it doesn't matter. But normally you start from 0, 1 anyway. So, and starting from 0 would make it like this, but it's given there, so you don't need to scratch your head. Okay, let's look at the next question. But look at the fact that we use the formula to get the learn, the power series for the learn. We use the fact that we know the formula of 1 over 1 plus x, and then we can integrate 1 over 1 plus x because you know the integral of 1 over x. What is the integral of 1 over x? It's the ln of x. So we use that because the integral of 1 over x is the ln, and then now this is just 1 over 1 plus x, which becomes the ln of 1 plus x. So we continue. Next question. Let's do this this one. We can use, in fact, that we can, in fact, show that the series for this and that converges for ln of 1 plus s converges to this one on the half open interval, and the series for this converges that. Okay, so you can show this, yeah. That's just, so now we want to show that arctan x is this. Okay, some of this, as said already, you're going to use integration for this. So you have minus 1 to the kth power, x to the power 2k plus 1, yeah, divided by 2k plus 1 for this. So now you then have, to get this one, you can use, because we know that arctan is from the integral of 1 plus x squared. But 1 plus x squared, we want to use minus, because the question, this tutorial said we must know the formula of 1 this, because 1 over 1 minus x is 1 plus x squared plus x cubed and so on. So you're going to use this one. But if this is the case, which is 1 plus yeah, so it becomes, the x is replaced by x squared, yeah? One minus x squared. And then you come to this one, you square it. You cube it. You raise it to the third and raise it to the fourth power. And then you have to the eighth power. Okay. Now you need to learn this trick. Just repeat these problems and try to make sense of them, because this is what the test is going to be about. No doubt about it. So you get to this, but when you get to this now, it goes on and on and on. And then what is this? This is the infinite series from k equals 0, okay? Obviously, this is going to be exactly minus 1 to the power k. Because it's alternate, you put minus 1 to the k. And then you look at the powers, 2, 4, 6, 8, they're all even, yeah? Okay, that's fine. But yeah, we've not integrated yet. We need to just integrate. Okay, what we've got is this one. If need be, you can come here and then say, divide here and then have 1 minus x squared, x to the fourth power, x to the sixth power, x to the eighth power. Then what is the next thing? Then you need to integrate. Integrate one, integrate both sides of this. So you integrate the 1 over that. Which is, okay, when you integrate this thing here, it becomes what? The integral of 1 is x. That of x squared is x cubed over 3. That of x to the 4th power is x to the 5th power out of 5. The one of x to the 6th power is x to the 7th power out of 7. And so on. Act an x integral. But this is the actually, if you check this, is the infinite series of, because the signs alternate, you can put -1 to the power k, x to the power 2k plus 1 divided by 2k plus 1. So we found the formula for the arctan inverse of x, which is this. How do we know these? Because how do we know that these terms are equal to this sum? You try to substitute. But as I indicated that each one can get their own formula. So, but you start from 0 and then work out the number pattern. 1, 3, 5, 7. Is it arithmetic? It is arithmetic. You use arithmetic from high school. The top is 1, 3, 5, 7. The odd numbers, use k plus 1 for the odd numbers. Okay, it's arithmetic. The common difference is 2, so use arithmetic series to find the power there. Okay, but yeah, I know very well that it's way too basic. So when k is 0, you have -1 to the power 0, positive. And then when k is 0, you have 2 times 0, 0, 0. And then this is x. When k is 1, to check that indeed this formula is equal to this. When k is 1, you must get this term. When k is 1, you have -1 to the power 1, which is that. When k is 1, you have x to the power 3, and then this is 3. When k is 2, you must get the 5. Let's check. 2 times 2, it's a 4 plus 1, 5, and 2 by 2, it's that. So, but how do we get this formula? I get your question. We use arithmetic sequence and series from high school to get the fact that it's going to be 2k plus 1 denominator. How do we do that? We can write 3, 5, 1. X is out of 1 here. 1, 3, 5, 7. What is the difference? 3 minus 1, 2, 2, 2. So you can use a plus a minus 1 into d. But you can't be using these things there because this is way too basic. We're interested in the integration part, not these arithmetic things here. Okay, so that the first term is 1 plus n minus 1. The common difference is 2. Which is 2n minus 1. Right, so you can get 2n minus 1. So that now if you 2n minus 1, you have 1 there, yes. 2n minus 1 becomes the formula for the 135. But again, if you start, this is when you start from 1. But when it's 2n plus 1, then you start from 0. Okay, so, but you can't be using a lot of the arithmetic there. What we're interested in is then saying, is this equal to this? When k is 0, do we get that? When k is 1, 2, 3, and so on, and then you say just this equals this. You know? I would imagine that what we want. But also, there's more to this. Because this series converge within an interval. I'm just mentioning this at this level of discussion. Okay. We have already said that, like this series, when would this series converge? This one. This series is going to converge whenever the modulus of is less than 1. Which means the modulus of x squared is less than 1. Which means x squared is less than 1. When is x squared less than 1? You need to solve that inequality. X squared less than 1 is x squared minus 1 is less than 0. Back to school, quadratic equations, quadratic inequalities. So this one, when x squared minus 1 is less than 0, you factorize. X minus 1, x plus 1 is less than 0. Okay, I'm just commenting on this thing they've said here. So when you get to this point, then you find the critical values, which are 1, minus 1. So you have this, and then you have minus 1 and 1. When this is negative, then you then say you go to the bottom, then it's negative. Okay, so when is this quadratic negative? When minus 1 is less than x less than 1. And hence the comment by the person who wrote this tutorial later. From minus 1 to 1, then this is when the quadratic is negative. And we have this. But this guy is claiming that this is going to be at 1 and this cannot be minus 1. Yeah. Okay, it can be 1 because, and then it can be minus 1 for this one. So here you can just include the extremes because the arctan of 1 is defined, but also the arctan of negative 1 is also defined. So you can say this is correct. It is its interval of convergence closed. This is half open. Now, for the 1 over 1 plus x, the log is not defined in some places, like when the log of a negative number is undefined. So you come back to this. You'll come back and then say, this log came from the fact that this must be so, which means therefore that the modulus of x is less than 1. Okay, so that when x is 1, when x is 1, then you have x is 1, 1 plus 1 is 2, ln 2 is defined. But when x is minus 1, then you can't have x is minus 1 plus 1 gives 0. Ln 0 is undefined. So it is correct, therefore, to say for the ln, then you need to have this interval here. Okay. Okay, obviously now we're going to take a break. I'm going to get back and explain this section from the beginning. So right, I will see you again at 10-ish. We can do 10 if you're free. We can look at the things because now this is 4. Let me see what question 5 is about. Yeah, okay, 4B gonna be doing this, okay? Right, it's fine, we've done this now. 10-ish. Okay, I'll check with you at 10. If you're free, then we can continue and do more. We can go back to some basics, but refer to the scope. Here's the scope. Refer to the scope. Here's the scope. Okay, I've taken it from WhatsApp. The techniques of integration, the trigonometric substitutions, and the partial fractions. We've already spent time on the partial fraction, the trigonometric substitutions, and techniques of integration. The improper integrals, we've already spent time on them. First order differential equations, we spent time on them. Separation of variables, we spent time on them. Integrating factor, we spend time on them. The infinite series, the geometric series, the Maclaurin series, the Taylor polynomials, the Maclaurin-Taylor power series, differentiating, integrating power series. We've done everything. But we're going to return at 10 and do more. But I'll check with you when you're free at that time. But here, there's no binomial series, yeah? No binomial series are going to appear. So you can be at ease. But also leave out applications of the first order differential equations, the separation of variables, and the integrating factor. Like the applications will appear in the form of the polonium and so on, like this. Like this. Polonium-210 is a radioactive element with a half-life of these. They said these are applications of differential equations. So they said, please, 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 please leave them out. That's what they said. So just looking at that, where they said, please leave them out. So they said, leave out applications. Right. I must thank you for joining us. That's awesome. 10. I'm going to check with you that time. If you're free, we can get back and, discuss this stuff. Okay. And can we even go back? I don't know. Whatever is worth discussing. Okay. I must thank you, Dave, for joining us. Until 10, I'm going to check with you when you're free at that time. You can do more. But as from us from now, take care and goodbye for now. Goodbye.